Okay, so I want us to um solve or some questions on a normal form. Okay, while solving the questions, I will explain what we meant by a normal form for a linear differential equation. Okay, so for a system of linear differential equations, sometimes you'll be given to write the normal form for certain systems of linear differential equation. Okay, so the idea is that you just reduce the equation that they will give to us into a first order, and we use that by using a transformation. So we will transform all the highest value in such a way that the least one becomes our first order systems of linear differential equation. Okay, so we have some questions to go through. Y prime prime of t plus a1 y prime prime of t plus a2 y prime of t plus a3 y of t is equal to f of t. And this the second question. So we will be solving the first question. Whilst I'm solving, I will be explaining the normal form so that we will all understand. Okay, so we can notice something here. You see, the highest order, which is the of power 3 or of the highest order, okay, is 3 or third order. You see, it is reducing. We came to second order, we came to first order. Now, see, so we can notice the trend. So that's what we are going to do. So we choose a certain value, say s naught, but I always prefer the s naught so that the naught there refer or make me know that that's my starting point or the initial point. So I'll choose a value for my dependent variable, which is y, as a function of x. So you just keep the highest order, which is the y exponent prime prime prime. You keep the highest order on your left hand side, or you keep it there, and you transfer all these terms into your right hand side. Okay, so that's what I have done here. Okay, so my y prime 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 will be given by f of t minus, because when it comes to the right hand side it will become minus. So that's what I've written here. Okay, so for easy, it will make us, or it makes it easy for us to solve. So this is what I was talking about. I will choose x naught as my starting point for my dependent variable y, because from the equation I know that my dependent variable is y. Okay, so we can follow the trend s naught, x1, x2, x3. So we can even see clearly that it's in a kind of increasing with values, that the subscript. So here was not, it came to x1, and it came to s2, and it came to s3. Okay, so let's see how we will obtain the x1, the x2, and the x3. This is what we need to go, or this is what we go about it. First, my initial or my starting point is my y of t, which is my dependent variable, is equal to x naught of t. So that's the first thing you need to know. Then you first, because the higher order is third order, it means we need to differentiate it thrice, three times. Okay, so you differentiate this, which is your y prime, then you differentiate it again, y prime prime, then you differentiate it again, y prime prime prime. Okay, so for my first derivative, which is my y prime of t, you will just differentiate this. Okay, so x naught, so the prime here, it means you have differentiated the s naught, so it becomes x prime of s naught of t. Then we subject it to x1 of t. Okay, just subject it to x1 of t. Now it is from naught. Now it has become x1 of t. Okay, and we come to the second part or the second order. So here we differentiate it two times. Okay, so we differentiate this one to two times, and it's the same thing as differentiating this one two times or differentiate this one once. Very simple. Sorry, or differentiating this one once. Okay, so always the one at the extreme. We are only focusing on how we can reduce the differential equation, which is of third order differential or third order derivative, to become a first order derivative. So that's the idea. Okay, so my first derivative, we had s naught s prime s naught of t. I differentiated this, so we just subject it to x1 of t. Okay, so I will just the y prime prime of t, I will just differentiate the s naught of t to two times. So you are going to get x prime prime of the naught of t, and it is the same thing as taking my extreme and differentiating it once. So when I differentiate my extreme once, the extreme is x1 of t. So when I differentiate this one once, it gives me x prime prime of t. Simple. Then you subject this one to another extreme. Now it's not x1 again. It becomes s2 of t. Simple. Okay. So you come to your third order, your y prime prime prime. That one to the same thing. You differentiate this one three times. So this is the first one, x prime 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 of x naught. Again, we know that here we've already differentiated this. Okay, this is the first order. So if you want the third order, you need to differentiate it twice. Okay, so you differentiate this one to twice. Okay, so it's the same thing as differentiating the extreme to once. Okay, it's the same thing as differentiating the extreme to once. So we differentiate your extreme to once. So now you are getting x prime of 2t, and you still subject it to x prime x3 of t. Okay, so very very simple. Let's get the whole concept. You see that from the trend s naught, s1 of t, s2 of t, s3 of t. Okay, so it's just a matter of you changing the variables or the subscript. Okay, so x naught, it goes to x1, s naught, it goes to x1, it goes to x2. Because we are differentiating this twice, it goes to from s naught, go to x1, it goes to s2. Okay, from s naught, it moves to x1, it also moves to x2, then it moves to x3. Okay, so it's very 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 simple. Okay, so after that, we are interested of writing it in terms of the first order derivative. We want the highest to be first order, not of third order again. So this is what we intend to do. We take my last two. So the last two is s naught prime of t. Then we equate these two. So we take the last two, we take the last two, then we take here to the last two. Why am I saying that? Because the last two exhibit the first order, the last two exhibit the first order, the last two here to exhibit the first order. So we will ignore the x2 and the x prime 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 prime. Okay, so that's what I've done here. So s naught of prime of t is equal to x1. Just take your extremes. Okay, the two extremes. So this. Okay, so let me circle it so that you see it clearly. So you just take your extremes, this, okay. Then you take your another extreme, this, and also take your another extreme, this. Okay, so that's what I've done um here. Okay, so after that we are almost done with the question. Okay, so it's just a matter of making a substitution. We saw that we made a substitution, or we made my y prime prime of t stand alone or stood alone, and we had f of t minus a1. So here we had our y prime prime to be, to see where's our y prime prime. It is equivalent to x prime of 1t, and it is equal to x2 of t. Okay, so it means in place of my y prime prime, just put my extreme, which is my x2 there. Whenever I see my y prime, just put the extreme, which is my x1, because this is my y prime. So it's just put the extreme, which is x1 of t. Whenever I see my y of t, my y of t is s naught of t. So that's what we are doing there. But here, my third order, which is my y prime prime prime, will be now written as x prime of 2, because we want everything in terms of x. Okay, so, and because we want the higher order to be 1, we will ignore the x prime prime of, you ignore this, the x prime prime 1 of t. Then we also ignore x prime 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 of x naught of t. So we will just come and take the first order. So this is the first order. X x prime of 2t is equal to x3 of t. Okay, so that's what I've written there. Okay, so that's the first order. So here now your ft comes minus your a1, by here your y prime is now x1 of t. So just make a substitution. Where is it? Okay, my y prime prime. Okay, my y prime prime is x2 of t. So just make a substitution, x2 of t. Then your y prime is x1 of t. Then your y of t, this y of t was s naught. So s naught of t. Okay, simple. Okay, so we always reduce the highest order to become always the first order. So that's why I've written the highest order is always reduced to first order in terms of x. Okay, so let's see how we can solve the second question too. The second question too says the square x dt square plus e exponent t dx dt plus t minus 1 x is equal to 0. Okay, so the square x dt square can be written as x prime prime, and also e dx dt can also be written as x prime, and this is this. Okay, so the same thing, just make your dependent variable. As I said from the previous question, our dependent variable was y. Okay, but here the dependent variable is x. So just make your dependent variable, which is x of t, to be equal to s naught of t. That's all. Okay, sorry, s naught of t. Okay, so you differentiate it once. Here, because the higher order is 2, we just differentiate it 2 times. That's all. So you take your first one, as I said, s naught, see the trend is reducing to x1, and now has gotten to x2. 2. Okay, so you take your s naught to be s of t to be s naught of t. You differentiate x, you are going to get x prime of t. So it means you differentiate this one once, then you subject it to x1 of t. Okay, then the same thing, you differentiate x prime prime of t. So you differentiate this one too, because we are differentiating it twice. You differentiate this one to s naught to twice. So you are getting x naught prime prime of t. Okay, then we subject it to, or and also it's the same thing as differentiating the extreme ones. Okay, so very 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 simple. And we subject it to s2 of t. Okay, so we are only interested in the extreme, which is s naught of t, s1 of t, and s2 of t. Okay, so here we just make this the subjects. That's the higher order, which is the square x, the t square. That's my x prime prime. So this can be written as this. That's why I've written it here. So it's the same thing. Okay. To make x prime prime the subject and make a substitution. So your x prime prime the subject, all this will come here. It becomes negative. So it becomes negative e exponent t x prime minus t minus 1x is equal to 0. Okay, so you know that x prime, we had our extreme x prime, we had our extreme to be x1. So we just put x1 of t there. Okay, and the s naught, the x of t2, we had s naught. So the x2, we just place s naught there. So that's why we place the s naught there. And with the x prime prime of t, we don't want in terms of x prime prime of t, because we want to reduce it to first order. Okay, so we come to the x prime prime column. What is my x? Okay, so you find your x prime prime column. You know that the only first order there is your x prime, x1 prime. So we just write your x1 prime. That's the first order of t. And we subject it. Okay. Okay. So basically, that's what we intend to do. Okay. Thank you very much.